Okay, cool. I am ready for another block of kind of live programming. So I'm going to continue this hash table implementation. So where I left off last time, I left off, of course, with a bug. So I want to try to solve that. And then I also want to do a couple of more things. So primarily, I think that this stuff here, so maybe some other more optimizations. So I think this also is kind of inefficient. That maybe I mean, somehow it will help speed things up if I kind of remove the need to convert this string to bytes, because I'm pretty sure it will be allocated to the heap, and then of course this thing is called a lot. So I'm doing like tons of heap allocations because this library needs that basically that string key be converted to a byte array. And then after that, I think last time I mentioned that I need some handling in case like the number of primes is the largest prime is currently exceeded. So I think I want to also add handling for that, because of course this exception, this panic will be raised. So yeah, so I think that's my plan um, for this block. And of course, like continue doing some benchmarkings on the side. So yeah, let's see. One thing that I did do um, before starting is just created like a GitHub repo. So I have here my .git thing. I also need a .git ignore as well. So I might have to delete actually, because it seems like I forgot to do the initial commit um, without a git ignore. So I think what I'm gonna do is go to my GitHub and delete that thing. So I'm gonna start with that first. I need to sign in. And then I need to do double auth. Double auth? No, multi-factor authentication. So let's see, multi-factor authentication. Where am I? Yeah. Okay, cool. So that is that. So maybe let's okay, so I want to delete this thing. Go look up. Delete. Well, doesn't let me delete or what? Yeah, delete, here it is. Okay, nice. So that's that. Okay. So okay, cool. RMRF.git. There it is. And I don't know why I closed actually my because I think I want to create create new, so go lookup. There it is. And okay, fine. Like this for now. Create repository. Nice. So, okay, here I am. Looking for Golang. Golang, come on, go. Go. Chuck it in here. Bam, there it is. VS Code. Okay, nice. Okay, so I think that's good. So cool. I'm gonna copy these commands. Okay. Okay, cool. There it is. So let me refresh. Yep. Perfect. Nice. Okay. Initial very late commit, of course. Nice. So I think that's gonna help me keep some things more organized. Nice. So okay, nice. So I'm gonna go to the test I was failing with, which is this delete, yeah, this resize down. Shit. No, not go run, but go test. Yeah, of course. So I left it on 3 because I didn't want it just to fail last video. So of course this will fail. Yeah, so basically what's happening here is that if I delete one thing, I want my active basically elements to be 2, because whenever something is deleted, it's basically the active counter is decreased, so it should be 2. And then since this is triggering a resize, also the occupied slot should be 2, because when an element is marked as deletion, as like a soft deleted, it will be deleted when the thing is resizing down. So the first thing I want to do is rename this actually to active slot counter, because that's how it is. So expected. And then here, That's annoying. Why would this do that? I'm just doing a shortcut here. Okay, that's annoying. I mean, for example, here, I'm still getting used to this actually particular shortcut. So what I'm trying to do, just a small parenthesis here. So shift end goes to end of the line, but then if I hold left arrow key, I go back, which is very weird. But then you can easily mistake like control. If you say control end, it will go to the bottom of the file, and control and shift are of course very close together. So I might have to like do a remapping there. But one thing that I don't think is ridiculous is that if I play shift end and then arrow key, it brings me back to the original position, which is ridiculous. Yeah, okay, anyway. Nice. So that is that. So of course, I'm gonna run this shit again. Nice, of course it's failing. And now I'm gonna go to my resize, no, sorry, delete. And now, okay. So I'm gonna do some print statements. So I'm just gonna print here just to make sure, of course, it's hitting this, or no, actually, no, here actually, just to make sure it is resizing. So fmp.println, and I'm gonna say just print the item, and okay. Why is this complaining? Okay, printf, fine. Okay, so I have soft deleted. Okay, so it is hitting. Okay, so soft deleted here is true. So now what I want to do is just do this item. Nope. Here, I'm just gonna say item A, just to make sure. So item A, yeah, false. Item A, true. Okay, cool. So more debugging statements. Okay, so I'm gonna go now to resize. Okay, so we have this, and I'm gonna go, but actually there's something I need to do before just to make sure, because just to run the single test. So it is run, and then I need to see the name of the thing, test resize down. Yeah, test resize down. Okay, nice. Okay, so now I want to basically check here for I think the key, and I think it's foo0, oops, So if item dot key equals full 0, printf, so item in resize, okay, nice. Run this thing again. Okay, so I have item A, and then the other one is true, and then item in resize, full 0 is, this shit is false. Okay. Oh my god, okay, now that's that is a bug. Okay, so I'm just gonna split this thing, go back to delete. Go back to delete. Okay, so I kind of, so this is like a classical thing that happens when you program. So here, what I can basically kind of think here that is happening is that this, I'm not, of course, operating on the same data. So this must give me like a copy of the, basically of that data struct. And of course, like this bug happened because I switched for these things, instead of for them to be like an array of pointers to the structs of basically the backing array of the hash table, I switched them back to like to store the actual data and not the pointers. So they're like being like references to the data. And then of course it's a struct, and I know in, for example, in languages like C#, structs are basically what are called as value types. So like, yeah, so you're not like operating on the real data. So I'm pretty sure this thing here is a copy. It's a copy of the data. So if I say like, if I say print, oops, not print, FNV-print line, no, print f, and I say item memory address, and this, and then I go item, like is it, yeah, ampersand, and then if I go fnt dot okay, so this should give me different memory addresses. Oh, ampersand. Okay. And I want to also add new line here so it doesn't get so messy. New line here. Yep, there it is. So it's essentially a copy because we have a memory address for this item, and then for the actual thing in the array, it's a different memory address. Okay, so yep, so that basically solves why this is not behaving correctly. Okay, that's cool. So I can delete this. I'm gonna also delete this, and here I'm gonna go to resize. Ah, my god. And I can also delete this now that I know what happened. Nice. Okay, so that means that I can have, I'll do a pointer to the thing. We'll do a point, yeah. And the item now, yeah, it's a pointer to data, right? Okay, cool. I can also delete this. Okay. So hopefully this should pass. FMT imported but not used. Okay. I'm gonna leave this one like that for now. And voila, haha, now it's passing. Whew, very nice. Whew. And I'm just gonna run as well everything, all the tests. Yep, nice, very nice. Okay. So that is that. So I'm gonna do this commit here. So, and I'm wondering, I saw Copilot actually. I had some, I don't know if it auto-installed the free version. Does it let me use the commit? Fuck it. Nah. Okay. Yeah. Okay. Screw it. Screw it. I'm gonna do it manually then. So fixed bug in what's that thing called? Yeah, leap. Okay. There it is. Oh yeah, yeah, yeah. So an updated test as well. So okay, fine. I'm gonna do 2 individual commits. And so updated test. Okay. Okay, cool. There it is. So I also want to check the README here. Yeah, okay, cool. I also want to run the good time to run formatting as well. I'm actually surprised it didn't put this shit, like, kept it on a single line. Fine. So okay, nice. So I think I'm also, yeah, I think I have to start populating this thing with more things soon. Okay. So the next thing I want to do is FNV. Let's take a look at this thing here. So currently, if I take a look at the README, so okay, I'm gonna say go test. Well, I'm just gonna copy this. Go test bench and benchmark with no resize. So that's the thing I added last time. And bench mem. Okay. So currently, and it also it's very sensitive to the input. It's very sensitive to, so maybe to get something more realistic. Oh my god! And then I forgot. I hope it can give it go test here in the command line, so I don't have to go and open that thing. Go. How is it? Help test. Go help test. I think. Yeah, and let's see. Time seconds. No. There's this particular flag. No, but it's not here. Or go help test flag, it seems. Go help. Bench mem. And where is it? Where is it? Where is it? Parallel. Yeah, bench time T, that's the thing. So I'm gonna say optional. Add for iterations for this. Okay. And then I'm gonna say here man, that's really annoying. I can't believe it. That VS shortcut is really annoying. Anyway, like 5 seconds. Okay. copy this. So I think one thing I'm going to do here is resources. So I'm going to just put the thing here. So go test testing package. So okay. So where is the flags? Let's see. Flags. Here it is. Okay, give me the option again. Yep. Okay, nice. That's that. Cool. Just gonna put it for 5 seconds. Okay. So this is the thing. So right now, to insert, basically, what's this shit is benchmarking, right? Is that to insert 1 million elements for 26 times. So this for loop ran 26 times. It was on average, so on average out of those 26 times of inserting a million elements, sequentially, it was 210 milliseconds. 210 milliseconds. And also 9.5 megabytes of basically allocation. So I'm just gonna keep somehow here. So just kind of before FNV hash. Okay. We're gonna keep it here for now. Okay. Which is quite a lot, and then I'm not sure if this is, I mean, I can compare it with Go, but I know Go will destroy me. Go's map implementation probably will destroy me. But I think that's going to be interesting, something I think I can try in a minute. Okay, so I'm going to go here. So yeah, so as I said, so there's two things going on. So this is returning, if I go here, open. So that's returning like some struct, right? Some struct. So, and also just as a coincidence, not as coincidence, but as curiosity, those when was this? 13 years ago. Wow, I don't know. Oh, okay. Yeah, well, I think actually this this thing, if it returns, it should return. It should not store in the heap, I believe. But this thing, as I said, definitely will. So this byte array. So basically, what's happening here is that this is being called many times. So if I go here to insert, shit. If I go here to insert, so this is calling hash one time, and if there's lucky, no, so minimum one time. But if there's like basically some collisions and this thing starts probing, it will call it more times. So minimum one time. That means that this thing is being like created. So there's definitely some memory allocation here for this one. And then this shit is being created like a million times minimum. Million allocations to the heap. So that's actually quite, I would say, a lot. And the longer the keys get, so for example, let me do an experiment. How can I like, yeah, no, not like that. So, oh yeah, actually, yeah. So I'm gonna see if this can make like a huge string. Let's see. So I'm gonna run this thing and it should be much more. Yeah, I'm probably gonna get a huge string. Hope I don't create any errors. But it should have much more memory consumption. So nine. So yeah, it was so almost 10 megabytes. 9.5. I thought it was gonna be worse. Let's see if I can like. Oh, untyped int constant overflows int. Okay, fine. Okay, wait. Let me see if I can do. Probably gonna still overflow. Okay. But maybe I would need more types of characters. Ooh, there is 10 megabytes. 10 megabytes, I believe. Yeah. So just in case it added an extra number. Bytes. Yeah, 10 megabytes. So let me do more, throw in more junk here. Something like that. So like a really long string. Yeah, it degrades performance like 308 milliseconds. And then 13 megabytes. 13 megabytes. There it is. That's crazy. That is insane. So I hope, okay, I'm gonna leave this like this. So I hope if this can be implemented. Okay. So let me let's go here. So hash FNV go. Let's see what hash function it uses. It implements the FNV1 and FNV-1a. Okay, so okay, I'm gonna go like this here. Yep, Fowler null bow is okay. Fine. Glenn Fowler. Almost said flower. Nice. So okay. So I'm just gonna also write here. FNV hash function. Say okay, nice. And then here's the pseudocode. So I think I was using the FNV, what is it? FNV-1a. Yeah, FNV-1a. FNV-1a hash. Only by the order in which the multiply and or XOR is performed. This one is deprecated. Offset basis FNV prime. FNV hash parameters. The above prime constraints and the definition of the FNV offset basis yields the following table of FNV hash parameters. Size in bits, 32 bits, 64 bits. Decimal and offset basis. Okay. So let me just copy this thing. And I'm gonna do this. I'm gonna copy this thing here. Okay. Okay, nice. Okay, I'm gonna recycle this, in fact. Okay. So we need a FNV prime and the offset basis. So FNV prime, I think we can make it a constant. So const FNV prime okay, and it's really handy actually. This gives everything, and it's also very trivial, huh? Very trivial to implement, which is really good. 64. So FNV prime. No, FNV. Yeah, FNV prime. So it's here. Okay. And I have this one here, which is the offset basis. So I'm gonna call it hash int64. And what's this complaining about now? It's not being used? Ah, okay, yeah, because it's like that. Okay. Nice. So now, for each byte of data. Okay. So I think I can go, oops. I can go length key. Or maybe, no. Let's, okay. What, I hope I don't forget this thing. Ah, here it is. I have the range here. So for I index, no, actually, what can I call this? I don't know. Full range key. Okay, that's the room thing. So char. Okay, so XOR. I forgot how to do the XOR actually. Golang XOR operation. Okay. And people say Stack Overflow is dead. I mean, of course, I could use Perplexity at the moment, but fuck it. Let's use Stack Overflow. No, but that's not the one I'm looking for. There it is. It's this motherfucker. Okay, yeah. So it's, yeah. I think it's probably in all programming languages actually. Let me check also Python. Python. Well, I don't know if all, but I guess it's quite standard. It is by the caret symbol. Okay. Okay, cool. So I guess should be, where's my caret symbol in the keyboard? No idea where it is. Okay, just gonna copy paste it from here. And okay. Byte of data. Char. Uint, do I have to say uint? Yeah. I have to cast that shit. There it is. Uint. And then hash times equals FNV prime times, oops, times equals, sorry. Okay. There it is. So now is the moment of truth. The moment of truth has arrived to see if my this thing okay, let's see. Moment of truth. Moment of truth. Oh, okay. Hash FNV. Oops. Come on. Come on. and then I have more collisions. What? $137. What? That's crazy. Okay, that is insane. And also I can see there is kind of a crazy thing. Like this can technically would be good to minimize the length of the string as well. Minimize the length of the string because somebody can, or I mean, it's not gonna be in production, but you can imagine like you can have like a huge string, and this, and yeah, that's interesting. I cannot believe it. I didn't really shave off. I was expecting to shave off much more. 137. That's crazy. That is insane. I cannot explain it. Hmm. That is truly insane. Ah, yeah, no, same iterations. 207, and then I have. Okay, wait a minute. I'm gonna clear this. So I'm gonna clear this thing for a moment. So let me just wanna do it again. Just wanna do it again. Okay. Oh, come on. Okay, nice. And then okay. Come on. Okay, so the good thing, at least the number of collisions is the same. The number of collisions is the same. Okay, so I'm gonna just put it. Ah, and it did more. Interesting. It did more. Okay, no. I have to do this shit again. So I think I have to control manually the number of iterations because it's giving me different ones for some weird reason. Okay. And what's? Oops. Oh, no. What did I do? This one is the one I want. So what is the syntax? 10x, so 5 times. No, yeah, let's go for 18. Or 20, 10x. Ah, sorry, no, I said 20. Yeah. Okay, here 20. Perfect. Okay, this is insane. So this took a little longer, in fact. It's almost the same. Ah, yeah. Ah, I thought it's almost the same. That is crazy. Why? This one is actually even a little bit better. Crazy. That is insane. But I'm not sure if this is actually then kind of like a naive way to do it. Okay, that's a mystery. This is a mystery. I'm gonna try to do it even like this is for the sake of it. What happens? 10x. Yeah. To be honest, I don't even know what is a good amount. A good amount to do this. I have no idea. Okay, so it's getting lower and lower. So I'm not sure if maybe, yeah, but it's probably gonna still be lower than the other one. Let's put 100x and see. With some crazy keys. Hope it doesn't take too long. Okay, 298. So maybe I have to find some kind of sweet spot. So, okay, let me just do something here. But I'm a little disappointed actually. a little disappointed. Okay. Okay. So this is different. This is way different. So this is a little bit faster. This allocates practically the same amount of bytes. Same allocations. But that's insane. I don't understand. I think maybe I'm doing something wrong. I don't know if the way I am doing this is wrong. Let's see if the logging fucks up stuff. Still diverging a little bit. It's even a little slower after removing the log. I think something is strange. Anyway, but I'm gonna leave it here. But something is definitely very weird. Um, would be good to find out. Going back. Um, yeah, it would be interesting to find out. Mm, yeah, maybe I'm doing the benchmarking wrong. That could be also possible. Okay, so since this practically also perform a little faster, I'm just gonna leave this one. I'm sorry, this one here. But that's yeah, that kind of things. Okay, so I'm gonna remove this. And here I'm not really like, yeah, allocating much memory either. Okay. I'm gonna rename this as well, just like so it's like debug actually. Debug. Okay. Okay, so nice. So I think, well, that's it. I'm a little disappointed, but I'm gonna keep going. Okay, so the next thing um, I want to try to do is to, yeah, basically write a get prime thing here. Um, and that should be only when we're resizing up, because resizing down, well, it's always gonna, um, well, I think, actually that is not true. It should be for both. Okay, so I think what I am going to do, we're actually, let me think. Say if I have a larger number, and then this prime is never smaller than that. Yeah, it will. Actually, it will always be smaller than that. So this is, it will always resize. So basically, is your number is larger. So if I have more prime numbers here, it will always resize down from whatever we can have like huge numbers to this one. That's like our kind of like our internal. I don't know if max capacity, but okay. So I think one thing I'm gonna do. So instead of for now panic, I'm just gonna say nil. And although I don't know if that's very idiomatic, but I'm gonna do that for now. Or very, let's say, idiomatic. Nil. Okay. And then nil. Or actually, no, I can return -1 because, yeah, primes are from 1 are always positive. So -1 is better. Come on. Ah, it's unsigned integer. Okay, so 0 because, okay. Can I return 0 like that? Yeah. And then I want to do the same here. I want to do the same here. Ah, I forgot actually to commit. I think this is a good time to commit. Okay, fine. I'm just gonna just revert these changes for now. I'm gonna leave this debug thing now for the time being. So Okay. Okay, now pick prime. Where should I write this? Maybe here. I think I should add this like to some helper method, just helper class or file module. But okay, so func pick prime, get prime. I don't know, get prime. Candidate maybe, UN64. Okay. So maybe I can say here next up boolean. Okay, whew. And then I can say I don't know what to call it, but init, let's say init prime for the time being. Okay. I think I should rename this to candidate actually as well. Okay. But I'm using it here. Okay. So I'm gonna say if init prime does not equal 0, return init prime. Or let's call this better, like found prime. Okay, so I have that. Just want to return something here so it doesn't complain. So if, okay, candidate next, so if we want to find the next size up, I want to find the next size up, I get this one, found prime, else this, and this returns 0 if they fail. If it doesn't equal 0, we basically found it. It's in the in these primes here. And if not, I have to compute basically the prime. I have to compute the prime. So compute prime number from candidate, and then okay. So now prime number. Return. Oh, I'm getting hungry. That is okay. Prime number. Prime number. Trustworthy Wikipedia. Give this thing in the link. Read me. Okay. Nope. Let's see if it lets me. Nope. Okay. Oh my God. Okay. Boom. Or I'm gonna say FNV. Okay. Fine. So yeah, just to have prime number is a natural number greater than 1 that is not a product of two smaller natural numbers. A natural number greater than 1 that is not prime is called a composite number. For example, 5 is prime because the only ways of writing it as a product is 1 times 5 or 5 times 1. Involve 5 itself, right? However, 4 is composite because it is a product of 2 times 2, in which both numbers are smaller than 4. I'm going to turn on the light. Or another light. Okay. Smaller than 4. The property of being, okay, simple but slow method of checking for a given number called trial division. Test whether n is a multiple of any, okay. Faster algorithms include this thing, which is a fast but has small chance of error, and the AKS, which always produces the correct answer in polynomial time, but is too slow to be practical. Particularly fast methods are available for numbers of special forms. Prime, blah, blah, blah. Primes, okay. However, random distribution of primes. But let me see this. But this is still looping as well. Yeah, this is crazy. N cubed. Yeah. But it said it was quick. Apply Miller test, testing against small number of variants for finding factors. So wait a minute. Fast way to determine if a number is prime. To quickly determine if a number is prime is to check for divisibility by prime numbers up to the square root of the input number. Okay. If none of these primes divide the number evenly, then the number is prime. For larger numbers, probabilistic tests like Miller-Rabin test can offer a faster, though not always definite answer. Okay. So let me see. Does this say square root? Lots of the only square roots of. Here's a proof that if n is a prime, then the only square roots of 1 modulo n are 1 and negative 1. Still. Modular square root. Okay. Again, so yeah, wow. Observe that the safe era. So Greeks can be, okay, the Greeks found this. Can be sped up by considering only the prime divisors up to the square root of the upper limit. What else does it say? If the Riemann hypothesis is true, these fluctuations will be small, given by the prime length of about the square root of x for intervals near a number of x. trial division. So that's the bad thing. Okay, so calculate the square root of the number you are testing. Create a list of prime numbers less than or equal to the square root. Okay. I also, yeah. The prime number is a whole number, one. The first few prime numbers are 2. Okay, yeah, 2 is a prime. Ah, interesting. So 2 is 2 an even number? I think it is. Yup. Okay. Interesting. So the only prime number that's even is 2. The only prime number that is even is 2. Okay, so let me see. Func okay. I think I say candidate. Okay. So, okay, so we have this. So the only prime number that is even is 2. But actually this should be, not candidate, but okay, so for okay. So the first thing that I need to start is, so start, so I start, I think, should always be an odd number. Should always be an odd number. So that means that if input modulo 2 equals 0, so we're gonna say start start equals input plus 1. Ah, come on. So annoying. Okay. Start. smaller than count. What can be count? So yeah, so I'm gonna start at the input. So I'm gonna try to computing it. So the start is gonna be the input value, of course, that we did here, and then up to. It has to be up to. So I think it has to be up to. So the limit or limit should be the max uint 64 in Go. Okay. Max. So Golang language reference. And I'm also gonna actually put this right away here. Okay. So I'm gonna search here uint 64. Ah, there it is. Ah, shit. Ah, yeah. The set of all unsigned integers 0 to this number. But is there a simpler way to get it? Okay. I'm just gonna have this for now here. Const max uint 64. Okay. Okay, but then it has to be always plus plus equals 2. It's because, for example, let's say I have 20, then 20 is even, so it's going to be 21 because it's plus 1. And then 22 is even because it can be divided by 12, I believe. 11? 11 times 2, 22. Yeah. 11 times 2, 22. 22 divided by 2, 11. So then that should become 22. And then 22 is, I'm not sure if it's going to be prime itself here now, but it's odd. It's an odd number. So actually, no, 22. No, it's 21. No. That was stupid of me. So 21 divided by 2 is 10.5. Oh no, but this is still not yet to this. Okay, I'm gonna just gonna test. Ah, fuck. Oh my god, I'm an idiot. 20, 21 plus 2 is 23. Oh my god, okay. Jesus. Okay, fine. The pressures of recording and doing this type of stuff. 23. Nice. So the next thing I want to check, so check I is prime number. Check if I is prime number. So I think this is where I start to do the square root thing. Calculate the square root of the number you are testing. Create a list of prime numbers less than or equal to the square root. Okay, calculate the square root of the number you're testing. Okay, so and what is the other thing? Oops. Create a list of prime numbers less than or equal to the square root. Ah, but this is trial division. Okay, I'm not sure how. Okay. I'm not really sure how efficient this will be, but okay, so I'm gonna say like no, limit math dot square root input. Okay. No, float 64. Float 64. Um, so now I think I have to loop, perhaps. So up to limit, so up to the limit, so until up to the square root of this. What the hell? What's this complaining about? You. So start. Okay, so let me do something here. So let's say I have 23. So the square root of 23 So where is the square root? It's not this. Okay, fine, yeah. So 23 is 4.79. I'm not sure if that will round it to 5. So let's say this is 5. So it has to start from 2. So 2 is prime up to 5. And 3, is it? No, actually from 3 and then again plus 2. So this essentially will test 3, just 3 and 5. Not so exciting. Or just 5 actually, in fact. Okay. So I'm going to say if input modulo I equals 0, return maybe like continue. So here you will say return would be return I. Okay, this is complaining again. Okay. So if this input, oops, modulo I, not 1. Okay, so we're saying 23 if 23 modulo 1 is 0, continue. Because this means this will be even. This will be even. And yep, here is, well, in fact, well, I was lucky what I chose. So here, in fact, 23 is prime. Nice. So then 23 is prime. So we go here. It will return immediately 23. So, yep, it will return immediately 23, and then here but actually pick largest length. There has to be also somewhere check if candidate exceeds max length 64. So this will return 23. But what happens? It doesn't find anything. Negative. Okay, so it doesn't find anything, so 0. Or I'm going to say is 1 a prime number? Zero or 1 are not primes. Ah, it's 1, 2, yeah, so 0. Yeah, yeah. So I don't know if here if to throw in a panic. Ah, okay. So yeah, okay. So compute prime number candidate. But okay. And also I think I'm gonna say this is candidate as well. I don't know if there could be an optimization here. Okay, fine. So I'm just gonna do this for now. Compute prime number. Okay, 164. So actually I want to panic. Maybe if found prime equals 0, let's panic. Prime prime could not be found. Okay, so this, so maybe I can wrap this in something else. So maybe let's say func get okay. So okay, so that's the check, and then here get prime. Okay, but this is next size up. Okay, so I can do it actually. Or actually, what will be cleaner? two functions, compute next size up, next size down. Yeah, why not? Okay. Now, but I'm pretty sure here it will fail. So, okay, let's see. I'm just gonna do the multiplication. Like that in place. Okay. Even 64. Nice. So this will never exceed because it will always go down. Okay, candidate. False. Okay, nice. Okay. And now I can replace this with new length. So compute next size up. Okay. Okay. There it is, I think. Oof, getting quite late. But I should also write some unit tests. Oof, but I'm getting so hungry. So hopefully nothing will break. Ah, nice. Existing tests. Okay, everything passing. So now what I want to do, something quick. Get prime. What happens if the candidate is already a prime? We'll pick the largest one. Yeah, straight away. Okay, I'm gonna do. this should be, okay, I'm not gonna complicate myself for the moment. So let me maybe do this here. So func get prime, and I think this is the last thing. Test get prime. And let's say, I'm gonna say I'm gonna say 23. Okay. Next size up, fine. Next size up. Yeah, why not? Okay. So next size up for 23 should be 37. Expected. Come on. Oh, come on. To be 37 got 23. Okay, wait a minute. Ah, yeah, largest or equal to. Yeah, sorry. There it is, so it'll be 23. Yeah, forgot. Largest or equal to. Not largest. Okay, nice. Cool. So that is that. And so now, if I'm just gonna do another one really quick. Oh my God, this is like, so I suppose, let's say 23 times, so 23 times 2 is 46. What? What is this complaining about? Okay, yeah. 46. And then expected so 46 has to be 53. No, but I also need to trigger something outside of this thing. forgot to call get prime. Bam, there it is, nice. So now I'm gonna trigger something outside. Maybe 2. I don't know, something like that. Something like this. What would be the expected value? I have no fucking idea. I have no idea. But yeah, I have no idea what prime number calculator. No. Oh, I don't know how to test this right now. Okay, so I know this will trigger this. Compute prime number. Just assert it doesn't equal 0, basically. I want to do that first of all. So, but then will it panic? Yeah, I will panic. But still. Um, what? Prime number cannot be found. Shit. So there is a bug. Ah, this should be J, I think, as well. Wait a minute. No, I think this shit is wrong. This shit here is not correct. I think it's also, I think this won't fix it. Just a small detail. Okay. you know, let me do this and run I'm gonna say 195, just smaller. Or even, yeah, why not? Or let's say 100. So square root of 100, it's 10. Is it? Yes, 10. So square root of 100, so this is 10, 10. So from 3 to 10. Three to 10. So there's the first one. Start is 100. So it's 101. Yeah, so still 10. So 3, nothing is done. Do I have to? Okay, wait a minute. I think I want to do this. Maybe this also is a little cleaner. So this will be true. Uh-huh. Nice. Okay, 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 okay. So, yep, I had the logic, yeah, completely wrong here. So, yeah, so the thing is here, basically, if I find any number, I think I can put this back to I. Come on. So if I have any number, so 101, I said limit is 10, right? So I said 10, so from 0 to 10 to 3. So it's 3 moduli, so yeah, it's not, it doesn't go, 3 moduli, it's not even. Then 5 is not, then 7 is not, 9, and then 9 divided by 2 is also not even, so it returns true. It returns true here. Okay, yeah. If even return false. Now I want to also look what is a quick way to I think there's more efficient way. Then I then compile these two with blah blah blah. I found that in each case the output were identical. They both used the okay. I don't know. I'm gonna yeah have this one actually. I think it's a bitwise operator. I like to keep integers and truth values separated conceptually, so I prefer to write. Okay, fine, whatever. I'm gonna keep it like that. Okay, now let me comment this out. Okay, so I think this check is redundant because I'm already panicking. So if, well, not me, but Go will panic. So if prime, yeah, what will be the next one up actually? 101. Did I say 100? Ta ta ta. Oop. And then from start 101. So it should be 101. So if prime is it? Yeah, nice. Yeah, 101. Okay, I'm gonna delete this stuff. Okay. Oop. So now let me test. I don't know what will be the result here, but what's up with this? Okay. Not sure what will be the result, but as long as it doesn't panic. This will double it. So let's see. Yeah, yeah, of course. I mean, this one will fail. Yep, I have to comment it out. Ah, come on. So this one passed. I'm just curious. What is the answer? I'm just gonna okay, no, it doesn't get me the log. But if I go like this, would it? Is this the same? Yeah, it's the same. Why is it the same? Ah, of course. Should be the same. I need to multiply it. Oof, okay. So there's more, yeah, more tests to write here, but I'm getting quite hungry, so oof, and it's quite late already. So I'm gonna, yeah, basically call it a day. I think it was, yeah, I think good progress. The only thing that I kind of got disappointed is um, this uh, this part at the beginning. But anyway, it's fine. So let me. Okay, so added okay. Maybe the last thing I'm gonna do here is um, go look. Yep, passing implementation reading Golang, just for fun. Um, okay, so I think for now I'm gonna do that. So Added resources section. Nice. Whew. Whoops. I should have formatted before. So oof, okay, this is it. I don't know if people stayed until the end. I hope it was interesting. It was a long one, but I think, I mean, I don't really know exactly when to basically halt, stop this. There's many things like I think that can be done. I really want to try to see if to benchmark Go's internal, yeah, their own hash table implementation. But I'm sure it will probably destroy mine. Yeah. So yeah, perhaps I'll do maybe one or two more, and then let's see what happens. Let's see where this goes. But it's definitely much more robust than the Python one. So the Python one, yeah, there was like some details I left off. It was meant to be more like a simple implementation, but then this one I'm taking it much further, which is good. Um, okay, so that's it. Thank you. Have a good evening or morning or afternoon, and hopefully see you very soon.